All right, ladies and gentlemen, so back in Algebra 2 and back in Pre-Calc, we did do some work with series and sequences. So first of all, let's just review the difference between a sequence versus a series. What is the difference between the two? Well, a sequence is just what? A sequence is just a list of numbers. So it's a progression of ordered list of numbers. However, the series is when you have a numerical value when you add up all the terms of the sequence. Again, when we talk about the infinite series, again, it's an expression that can be written in the form of, again, here's, remember, your sigma notation, which means you're taking the sum. Your lower index tells you exactly what term of the sequence you're starting the sum. The upper index is where you're adding. So in this case, again, it's going to infinity. And then you can, again, list all the terms you're going to add together. Remember, the plus dot 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 means it's going on forever. And you studied a special series back in Pre-Calc and Algebra 2, which was your infinite geometric series. There's certain cases where you actually can find the sum of an infinite series. And we'll talk about that in a little bit. Remember, the use of 1, use of 2, use of 3 are called the terms of the series. In most cases, we cannot actually calculate the infinite sum, even if we know that it exists. We can start by examining the sequence of partial sums. So when we are considering this particular series here, 1/2 plus 1/4 plus 1/8 plus 1/16, and so on, the first partial sum is just the first term. The second partial sum would be the sum of the first two terms. So we can, when you have an infinite series or have a series calculus called a partial sum. The nth partial sum is just the sum of the first n terms. So for example, if you're asked to find the first partial sum, you just simply write down the first term. The second partial sum would be by taking the first two terms and adding them together. So 1/2 plus 1/4 is what we call the second partial sum. So what is 1/2 plus 1/4? That's just going to simply give me what? 3/4. The third partial sum would simply be the sum of the first three terms, the 1/2 plus 1/4 plus 1/8. So 3/4 plus 1/8 will give me 7/8. And then again, your fourth partial sum would be just the sum of your first four terms. So any questions when I ask you to calculate a partial sum, how do you do it? So your fourth partial sum is 1/2 plus 1/4 plus 1/8 plus 1/16. Again, that would give me 15/16. Okay? So now, again, what is S sub n? Again, that would be your sigma notation. Again, your lower index will say k is equal to 1 to infinity, because again, we know that this is going to infinity. What kind of series is this? You should recognize this from your study. This is what? Remember, you studied two different kinds of sequences and series, arithmetic and geometric. Do you recognize which kind this is going to be? Geometric. A geometric has that common ratio. What is the common ratio of this particular series? 1/2. So remember the way you write the formula, the explicit formula for a geometric series or sequence is going to be a sub 1, which is 1/2, times the common ratio. Looking here at this particular list, what is your common ratio? 1/2. Again, in this particular case, it's just going to be to the k. So any questions on how I wrote the formula? Again, because remember it's going to be a sub 1 times r to the n, or depending upon where you're starting in your list, a sub 1 times r to the n minus 1. Yes, Kevin?
Why is it just like, I mean, like, why isn't it just 1/2 to the k?
Oh, it should be k minus 1.
Okay.
Yeah, it should be k minus 1. If I started this at 0, then it would be 1/2 times 1/2 to the k. So it depends upon whether you're starting with the first term of 0 or whether it's going to be a k or k minus 1. Thank you. What's the limit? As n approaches infinity, or in this case it should be k approaches infinity. Do you remember how you can calculate the sum of a infinite geometric series? Remember, if the absolute value of r is less than 1, calculate the sum of your infinite series. Remember, the formula is a sub 1 over 1 minus r. So as k is getting really, really large, I want to know what this sum is approaching. So I want to calculate what the sum of this particular infinite series is going to be. Well, my first term is a half divided by 1 minus 1 half. So what is this limit as k approaches infinity approaching? It's approaching what? 1. Now, on your calculators, ladies and gentlemen, depending upon the version of the calculator you do have a sigma. If you've got the updated 84s, with the updated operating system, you can find your sigma notation by going under alpha window, option number 2. So alpha window, option number 2, you will see that you can actually have your sigma button. So again, you can type in on your calculator the lower index, again, x equals, oh my, sorry, I changed my note back to function. So again, I can type in x equals 1, I can type in 100, type in a really large number. Type in your explicit formula, that 0.5, oops. 0.5 times that parentheses 0.5 raised to the x minus 1. And notice it's going to give you that value of 1. So if you do have an infinite series, and if it is approaching a fixed number, if it is converging, again, you can only find the sum of your infinite geometric series if the absolute value of that common ratio is less than 1. If you do not have the updated operating system, if you have the old 83s, here's the instructions on how you have to find the sum using your 83s. All right? So now, if you've got, like I mentioned, if your sequence converges to a limit, then we say it's said to converge to S, and we call that the sum of the series. If the sequence of the partial sums diverges, then we say the series diverges. Remember, a divergent series has no sum. All right? So we're going to study for the remaining part of this chapter a lot of other series besides the geometric series and trying to figure out the convergence or divergence of the series. But the first one that you're actually already familiar with is the geometric series. So like I mentioned, remember, a geometric series has a common ratio. Again, we state that if this series converges, the absolute value of your common ratio has to be less than 1. If it diverges, remember, the absolute value of the common ratio is greater than or equal to 1. And like I just showed you, this is the formula. If you do have the absolute value of the common ratio that's less than 1, this is the formula you can use to help you calculate what it's converging to, or what is the sum of the infinite series. Whenever possible, ladies and gentlemen, you want to try and always write your formulas in the form of a sub 1 times r to the m, or to the n minus 1. So when you're trying to decide whether or not you've got a geometric series that's converging or diverging, this is going to be very helpful when we start getting into all the different series we'll be studying in this chapter, because geometric is one of the easiest to recognize whether it's going to converge or diverge. So for example, let's take a look at this geometric series and decide whether it converges or diverges. So if you cannot figure out what this formula is, so suppose that you're struggling on figuring out how to rewrite it as a sub 1 times r to the n minus 1, you can always list the first 4 or 5 terms. List about 4 or 5 terms to see what that common ratio is going to be. So if you're not quite sure what the a sub 1 times r to the n minus 1 formula looks like, you can always write out the first 4 or 5 terms. All right, so for example, let's take a look at this particular infinite series. K is equal to 0, raised to the infinity power. Well, first of all, we have negative 5 divided by 4 to the k. So there's another way I could rewrite this fraction. Again, remember, I want to get this ratio raised to the k power. So I could rewrite this particular explicit formula as a -5 times 1 over 4 to the k. Would you agree with me that these two expressions are equivalent? Are they equivalent? Now, again, if you have a 1 in the numerator, again, 1 raised to any power is still going to be equivalent to 1. So I could now rewrite this as k is equal to 0 to infinity of -5 times 1 over 4 raised to the k power. So now, what is the common ratio? So now I know for sure that this is indeed a geometric series. I can now identify what the common ratio is going to be. What is the common ratio for this particular series? 1/4. And is the absolute value of 1/4 less than 1? Yes. So would this geometric series converge or would it diverge? Converge. So I know that this series is going to converge. Now it's asking me to find the sum if it also converges. So to find the sum of your infinite series, I have to find my first term. What is the first term of this particular series? Now be careful, this one's starting at 0. So the first term would be what? -5 divided by 1 minus your common ratio of 1/4. So then what is this particular series going to converge to? It's going to converge to what? Well, -5 times 4/3 is going to give me -20 over 3. So like I said, if you have trouble identifying how you could rewrite this particular explicit formula, you could always list out the first couple terms as well. All right, so any questions on knowing, but as we move through this chapter, it's very helpful if you can get that skill to write as a sub 1 times r to the n minus 1 to the n. Let's take a look at this next one. 3 times 3 raised to 2k power, 5 raised to the 1 minus k power. So again, this is one where you may want to just write out the first couple terms. So again, what is your first term? Your first term is going to be what? 9. Your second term. (81 over 25) or 81 over, I think that's 5, isn't it? 81 over 5. So what do you think your common ratio is now going to be? Your common ratio is going to be what? 9 over 5. So now what's the absolute value of 9/5? Is that less than 1 or is that greater than 1? 9/5 is going to be what? Greater than 1. So since it's greater than or equal to 1, then will this series diverge or converge? Diverge. So any questions on B? Now let's take a look at C. Again, you have another infinite series. Again, remember we're starting at k is equal to 1. So we have 1 over 2 to the k minus 1 over 2 to the k plus 1. So rewriting this in terms of a sub 1 times r to the n minus 1. First of all, I would combine this into a single fraction. Plus, I would rewrite this 2 to the k plus 1 as 1 over 2 to the k minus 1 over 2 to the k times 2 to the first. When you go to get that common denominator, I would rewrite that 2 to the k plus 1 as a 2 to the k times 2 to the first. Because now what are you going to have to multiply this first fraction by? You already have the 2 to the k, so we need to multiply top and bottom by 2. So I can rewrite this 2 over 2 to the first times 2 to the k plus 1, or 2 to the k, minus 1. So again, all I did was multiply the top and bottom of this first fraction by 2. So then the way I can rewrite this is 1 over 2 times 2 to the k. So any questions first of all on how I combine this down to a single fraction? So now hopefully you can identify how you can rewrite this explicit formula in the term of a times r to the nth or a times r to the n minus 1. So again, I have my constant of 1/2 times 1 over 2 to the k. You agree with me that that's equivalent to what I got after I combined that? So now 1 over 2 to the k, to raise that entire fraction to the k power, I can rewrite this as k is equal to 1 to infinity of 1/2 times 1 over 2 all raised to the k power. So what is the common ratio for this particular series? The common ratio is going to be what? 1/2. So the absolute value of 1/2, is that greater than 1 or less than 1? Less than 1. So is this series going to converge or is it going to diverge? Converge. Any questions on why this particular series is going to converge? So now you tell me, find the sum, tell me what this is going to converge to. Careful, we're starting at 1, so the first term is going to be what? First term is in a half, and the first term is 4. Everybody come up with 1/2? So you guys go ahead and try D for me. Go ahead and figure out whether or not this is going to converge or if this is going to diverge. Again, if you're not sure how to rewrite it in the form of A times R to the nth or A times R to the n minus 1, write out the first couple terms to identify your common ratio. Is this going to converge or is this going to diverge? Diverge, I agree. Why is it going to diverge? What is your common ratio? The common ratio here is what? Negative 3 over 2. The absolute value of negative 3 over 2 I know is going to be greater than 1. Okay? So any questions if you've got a geometric series, how do you know whether or not it's going to diverge or how it's going to converge? So here's another application of the geometric series. We're all familiar with repeating decimals. So here they're giving me a repeating decimal. Find the rational number represented by the repeating decimal 0.51, 0.51, 0.51, 0.51. Well, you can actually take your repeating decimal of 0.51, 51, 51 and expand it out as a sum. So I could actually rewrite this repeating decimal as 0.51 plus 0.0051 plus 0.00051 and so on. Do you agree with me if I add all those? And I can just keep on going. Because now what I'm basically trying to do is, we all know how to get a repeating decimal when I take a fraction and I divide it. I'm basically going backwards. I want to know what fraction this came from. That's basically what I'm trying to figure out. So basically, what kind of series? So this is a series. What kind of series is this? Geometric. This is a geometric series. Because I know my first term is 0.51. What's your common ratio here? Your common ratio is going to be what? Doing what? Not 0.51. 0.01. Remember how you can find the common ratio. If you're not sure what the common ratio is, you take a term and you divide it by its previous term. So if you're not sure by looking at the series whether or not what the common ratio is going to be, you can always find it. So if you take 0.0051 and divide it by your 0.51, that's where we get the 0.01 from. All right? So you can always find that common ratio if you're not sure what it is. So I know if I've got a geometric series, and I know in this particular case the absolute value of the common ratio has to be less than 1 to converge. So I just found that my common ratio is 0.01. So we know that the absolute value of 0.01 is less than 1, correct? So I know that this is going to converge to some number, and that's the number I'm trying to find. So how can I find the number that it's going to converge to? Well, I'm going to take my first term, which is 0.51, divided by 1 minus the common ratio. So I end up with 0.51 divided by 0.99. And what is that fraction going to be equal to? That fraction will be equal to what? 51 over 99. And if you take 51 over 99 in the calculation, you get that. So that's just one application. So there's a lot of other applications of what you've been studying about the geometric series, and here's one of them. All right, any questions on this particular example? How do you take a repeating decimal and then convert it back into the ratio? Yep. Scroll down a little bit. Alright, so let's take a look at the next one. So use the geometric series to show that this infinite series, -1 to the k, x to the 2k converges if your x values fall between -1 and 1. Well, first of all, it's a geometric series. So I know that to show that it's converging, I know that I'm looking at the sum of my infinite series as a over 1 minus r. So first of all, what I have to do, in order to converge, I know the absolute value of your common ratio has to be less than 1. So anytime they're talking about the convergence of a geometric series, these two things always have to pop in your mind. So if anytime you talk about convergence of geometric series, just remember the absolute value of its common ratios have to be less than 1, and this is what it's going to converge to. So I always write these two things down to begin with. So now, first of all, I have no idea what my common ratio is going to be. Well, remember, how can you find your common ratio? You can take a term and you can divide it by its previous term. I'm starting this particular series at 0. So let me start by finding a sub 0. What is a sub 0 going to be equal to? A sub 0 is just going to be equal to what? 1. A sub 1. A sub 1 is going to be equal to what? Negative x squared. So since I know that this is my first two terms, then to find your common ratio, I can take a sub 1 and divide it by a sub 0. So what is the common ratio going to be here? The common ratio is going to be what? Negative x squared. So any questions on where I got this particular common ratio from? So I know in order for this geometric series to converge, the absolute value of my common ratio has to be less than 1. So if I take negative x squared and plug it in for r, the absolute value of negative x squared has to be less than 1. So then to converge, I know the absolute value of x squared is going to be less than 1. So again, I can drop that. Now that I dropped the negative, I know x squared has to be less than 1. How do you solve that? It goes back to solving those quadratic inequalities. Factors. So what do we have to do? Well, first of all, we have to get 1 on one side. We have to get a. We want to get a 0, right? I heard somebody going to say you factor x minus 1, x plus 1 has to be less than 0. So remember, this is where you got those critical numbers from, and you have to do that number line test. Oh yeah, so what are the critical numbers going to be? The critical numbers will be positive, 1, and negative 1. So now remember, for this to converge, this has to be what? Less than 1. So it has to be less than 0. Remember, I'm solving this particular inequality. So when I do my number line test, I'm looking for what kind of numbers, positive or negative. Negative. So when I plug -2 in here, that's going to be a negative, that's going to be a negative, so I know it'll be a positive. Remember, you do your number line test, you take the numbers less than -1, you plug it in to see what's happening with the signs. If I plug in a number between -1 and 1, if I plug in a 0, 0 minus 1, 0 plus 1. What can you tell me about all those numbers between negative 1 and 1? They will be negative. And then if I plug in numbers greater than 1, these would be what? Positive. So that I know that numbers between negative 1 and 1, so that's how you show the convergence. Any questions on how you can show that a series? You basically have to find that common ratio, and again, substitute that common ratio, set it less than 1, and then end up doing possibly that number like this. Let's take a look at the next example. Find all values of x for which the series converges, and then find the sum for the series for those values of x. So again, to find those values of x where the series converges, that's where you're going to have to do the absolute value of r is less than 1. And then to find the sum of the series, that's where you're going to have to use your sum formula, the a over 1 minus r. So it's a two-step question they're asking us to do here. So here's my series, x minus x to the third plus x to the fifth minus x to the seventh. So again, how do you find your common ratio? We're going to have to do what? You can take a term and divide it by its previous term, or you may recognize what is your common ratio going to be here. Your common ratio is going to be what? Negative x squared. Again, if you're not sure what it is, you can take negative x to the third and divide it by its previous term. Yes?
It doesn't specify that the first motivation is the same.
Yes. Again, what will change here is it's going to depend. Your explicit formula can be written two ways based on whether you're going to start at 0 or 1. Basically, whether you're going to start at 0 or 1 will change whether you're going to raise the common ratio just to the nth power versus the n minus 1 power. So if you start most of your series at 0, when you write the explicit formula for your geometric series, it's going to be that common ratio raised to just the nth power if you start that series at 0. But if you're starting if your lower index is going to be at when n is equal to 1 or k is equal to 1, that's when you would plug in the n minus 1 as the power. So it just depends on how you're writing the explicit formula. So now, everybody okay where we got the common ratio? So again, to converge, remember I know the absolute value of common ratio has to be less than 1. So now that I know my common ratio, I can plug it in. The absolute value of negative x squared has to be less than 1. So that I end up with the same inequality, x squared is less than 1. So where is this series going to converge? What x values is this going to converge between? I already just solved this. It's going to converge between what? Negative 1 and 1. So any questions on how I found out where it's going to converge? And now to find the sum. To find your sum. Again, this is where I'm going to use this particular formula here, the a over 1 minus r. So again, the sum of this series here, what was the first term? The first term was what? X over 1 minus, we found the common ratio to be negative x squared. So then it's going to, the sum would be x over 1 plus x squared. So any questions on how I can figure out, given this particular series, how I can figure out at what values of the x will this converge, and then actually calculating the sum? Your lovely trig function, sine x minus 1/2 sine squared x plus 1/4 sine cubed x minus 1/8 sine 4th x plus da 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 da. So now, first of all, to figure out where it converges, I have to figure out the common ratio. So if you're not sure what the common ratio is, remember you can take a term and divide it by its previous term. So looking at this particular geometric series, what is the common ratio going to be? The common ratio will be what? Negative 1/2 sine x. So there's your common ratio. And again, to converge, what do I know about the absolute value of your common ratio? That has to be less than 1. the absolute value of negative 1/2 sine of x has to be less than 1. Well, since I'm doing absolute value, I could drop the negative, so this is going to be the absolute value of 1/2 sine x is less than 1. So now I can multiply both sides by 2, so I end up with a sine of x is less than 2. Remember back from your Algebra 2 days, when you had those absolute value inequalities, and it was a less than sign. You remember you rewrote this as what kind of inequality? You rewrote this as a compound and inequality, correct? You dropped right. Remember doing those? The ands and the ors? Absolute value inequalities. If it was a greater than, you'd rewrite it as a compound or inequality. But because this is a less than sign, you're going to write it as a compound and inequality. So we rewrite this as negative 2 less than sine x less than 2 to solve those compound inequalities. So remember, when you solve absolute value inequalities, you have the ands and the ors. You're looking at me like, I did that? Yeah, you did. Yes, you did. Yes, you did. I beg to differ because you have routes for 2.
Oh, no, wait. Okay.
Trust me, you did this in algebra 2. Yes, you did. When you solved absolute value equations, you solved absolute value inequalities. Yes, you did. Yes, you did. It was a long time ago. Okay, so now let's talk about this. Now going back to your trig days. What is your range of sine of x? Negative 1 to 1. So this has to be a true statement because the range of sine of x is only going to be from negative 1 to 1. So therefore, it is going to have to converge for all those values between negative 2 to 2 because the range we know is just from negative 1 to 1. All right? So any questions on how we show where it's going to converge? So your statement is, once you get down to this point, it does converge from negative 2 to 2 because the range of your sine of x is only going to be from negative 1 to 1. Yes, Evan? Yeah, that's
So not
right. So it's only going to converge from negative 1 less than sine x less than 1. Well, it has to converge from negative 2 to 2 because the only values you're going to get are from negative 1 to 1 anyway. So it's got to converge from negative 2 to 2. In fact, it's only going to converge from negative 1 to 1 because it doesn't exist for numbers smaller than negative 1 or larger than numbers greater than 1. So now we want to find the sum. So what was the first term here? The first term was what? Sine x. Over 1 minus what was the common ratio? The common ratio was this negative 1/2 sine of x. So if I clean this up and I simplify my complex fraction, what would I multiply everything by? Multiply everything by a 2. So I have 2 sine x over 2 plus sine x. Oh, yeah, no, because it's my common ratio. So any questions on the geometric series being able to figure out how to show whether it's converging and then show what it's converging to? All right. A next type of sums that are very popular is what's called the telescopic sum. So again, we're familiar. So now we're going to start studying all kinds of different series. So we're most familiar with geometric because that's what you've studied in the past. So a telescopic sum has a pattern where 2 terms are subtracted, then you're adding and subtracting. And the reason why we call it telescopic is derived from the fact that in simplifying the sum, 1 term in the parentheses cancels 1 term in the next parentheses. So for example, you see that b sub 2 in my first set of parentheses would end up canceling out with b sub 2 in the second set of parentheses. and then it happens with b sub 3, and it happens with all the terms. You'll notice a pattern of when the telescopic sum occurs. This will happen with the entire sum, and the entire sum collapses into just 2 terms, maybe 3 terms, but usually it's 1 or 2 terms, like a folding telescope. So that's why they call it the telescopic sum. The sum of a telescoping series is equal to b sub 1 minus the limit as n approaches infinity of b sub n plus 1. And eventually what happens, this is going to go to 0 because all the terms start canceling out to 0. You're going to be left with 1 or 2 terms. All right? This will not always, don't get careless and lazy. This will not always just be the first term minus the last limit of the term. You must write out the first few terms to decide which terms cancel and which terms remain. So the big thing is, just don't assume it's always going to be the first term that's going to remain in a telescopic series. Right. So that's why you got to write out the first couple terms to figure out which term's going to be remaining. So, for example, like I said, in this chapter, you're going to get a lot of tools to figure out what's happening with these series, diverges or converges. Determine whether the series converges. If it converges, find the sum. They're only going to ask you to find the sum of 2 series, the geometric or the telescopic. All the rest of the series, all we're going to care about is whether or not they're converging or diverging. So anytime they're asking you to find the sum, right away it's going to have to be a telescopic or it's going to have to be a geometric if you're dealing with the infinite series. Obviously, in the upper index, you can find the sum of any series. We're talking about the infinite series. So in the infinite series, if they want you to find the sum, you immediately want to be thinking telescopic or geometric. All right? So let's take a look at n equals 1 of 1 over n minus 1 over n plus 2. This certainly looks like it could be your telescopic because you have 2 terms subtracted together. So what you want to do is you want to write out the first few terms. So for example, I'm starting with my lower index of 1, so I want to find my a sub 1. So a sub 1 is going to be equal to 1 over 1 minus 1 over 3. Do not simplify any of your fractions when you're dealing with a telescopic. A sub 2 would be equal to 1 over 2 minus 1 over 4. A sub 3 would be equal to 1 over 3 minus 1 over 5. A sub 4 would be equal to 1/4 minus 1/6. So any questions of how I found the first 4 terms of this particular sequence? Yes, Osmond. Well, I'm going to list it a different way. All I did right now is find my terms. So now let me show what this looks like in the series. My first term, 1 over 1 minus 1/3, would be added to my second term, the 1/2 minus 1/4. Plus, this would be added to my third term, 1/3 minus 1/5. Plus, 1/4 minus 1/6. So now which terms are going to cancel? I have a negative 1/3 right here. I have a positive 1/3 right there. So you see how they're going to cancel. Would a 1/2 ever appear later on in this particular series? No. But I have a negative 1/4 here. I have a positive 1/4 here. So what's going to happen? Cancel. If I wrote out some more terms, would this negative 1/5 end up canceling out? Would the negative 1/6 end up canceling out? Yes. So what are the terms that end up remaining in this particular series? The only 2 terms that are remaining are going to be what? 1 and 1/2. So we can find this sum by taking 1 plus 1/2. So 1 plus 1/2 is going to give me what? 3/2. So it does converge by telescopic sums. So So you have to write out, like I said, a good 4 terms to see if it's telescopic, to see what terms are going to end up remaining. You've got to write out a good 4 terms to see which ones are going to cancel out. So by your telescopic sums, this series does indeed converge. All right, so any questions on what a telescopic sum is? So let's take a look at k is equal to 1 to infinity of 1 over k times k plus 1. Oh, your favorite. Partial fractions again. Because remember, this is not going to be geometric. So the only way you're going to possibly be able to calculate the sum to see if it converges is to see if it's going to be a telescopic. So to be a telescopic, you've got to break this up into the difference of 2 different fractions. So to be telescopic, you've got to break this up into 2 smaller fractions. That's why we need to do that partial fraction decomposition. So we have that 1 over k times k plus 1. We're going to break this up into 1 fraction, have a denominator k, the other one k plus 1. Tell me about the numerators. What are those numerators going to look like? Just a and b, right? So multiply everything by your LCD, I end up with 1 is equal to a times k plus 1 plus b times k. So what we will let k be equal to? K be equal to what? 0 and? So if I plug 0 in, what's a going to be equal to? A is equal to 1. What's b going to be equal to if I plug in a negative 1? Negative 1. So I know these fractions are going to be equal to 1 over k plus negative 1 over k plus 1. So like I said, anytime they are asking you to find the sum of an infinite series, geometric or telescopic, this is clearly not going to be a geometric series. All right, so this is where you want to be thinking of your telescopic. So if they only give you 1 big fraction, like a telescopic, you've got to have 2 smaller fractions added or subtracted together. So that's where if they're only giving you the 1 fraction, you want to break it apart. So now I can rewrite this series as k is equal to 1 to infinity of 1 over k minus 1 over k plus 1. So now, like I did in the previous example, to figure out if this is going to converge or what it's converging to, you want to write out the first 4 terms to see what terms are going to remain if it's telescopic. So again, this series is starting with 1. So I have 1 over 1 minus 1 over 2. There's my first term. My second term, 1 over 2 minus 1 over 3. My third term, 1 over 3 minus 1 over 4. And one more, 1 over 4 minus 1 over 5. And I know there's a lot more. So does the negative 1/2 cancel out? Does the negative 1/3 cancel out? Does the negative 1/4 cancel out? And then with eventually the negative 1/5 cancel out. So what's the only term remaining in this particular series? The only term remaining is a what? 1. So the sum of this infinite series is going to be a 1. So it does converge to 1. By your telescopic sums, it's going to just converge to 1. Yes, Don? If it's a telescopic, we know the signs, so you're going to have a negative somewhere, because we know that, remember, this question is, we don't know if it's converging or diverging. We don't know. That's why you've got to check for the telescopic or the geometric. So it's possible if you do the partial fraction decomposition, you go to write out your terms, you're going to see nothing cancels. And it's not going to converge or diverge. Yes, Don? Yes, Kevin, I'm sorry.
Are there any things in English which you have to do for us to notice that telescopic? Or do you decide
We have to figure out this way. Now, as we move through this chapter, as we move through this chapter, if I just asked you about the divergence or convergence of this particular infinite series, there's a lot of other easier ways to do just the convergence or just the divergence. However, this is where I said to you, anytime they are asking you to find a sum, there's only two series you're going to be able to find the sum for if it's an infinite series, geometric or telescopic. So if they're asking you to find out what it's going to converge to, you've got to rewrite it as the two partial fractions. Alright? Because this clearly wouldn't be geometric. I mean, you could look, you could plug in a number for 1, number in for 2, number 1 and 3. It doesn't have that common ratio between the terms, so that's where you have to check the telescopic. You're going to learn other tests this chapter. That's the whole point of this chapter. You're going to learn about a lot more tests to figure out converging or diverging. No, we have tests to do. That's the remaining part of this chapter is figuring out convergence and divergence of infinite series. But the only thing they're ever ask you about finding the convergence to, or finding the sum, is geometric or telescopic. That's why anytime in directions they say, what is it converging to, think geometric or telescopic. Only two series you can find the sums for. Alright? Yes. You should justify yes by telescopic surface. Or the telescopic series. Yep. You have to justify where your converging and diverging is coming from. I mean, you're going to see, we've got about 8 different tests you're going to go over in this chapter to figure out converging and diverging. I love that face you're making. That's why everybody loves chapter 9. All those lovely BC kids exact before you love chapter 9. Yes, Patrick. Yes. Yes. All right. So you guys go ahead and try part C for me. So you guys go ahead for part C. First of all, would it be geometric? No, it's not geometric. So since I want to know what this is converging or diverging, if it converges, what it's converging to, if it's not a geometric series, what kind of series do I want to look for? I want to look for a telescopic. So what am I going to have to do with this fraction first? I'm going to have to do my what? Partial fraction decomposition. So you guys go ahead and do that. Tell me, do your partial fraction decomposition, and then tell me whether or not this thing's going to converge or diverge and what it converges to.